Well, this screencast I think you're probably pretty familiar with based on what you learn in your social studies classes. Human population growth. Interesting statistics on this slide, so I left it in. Population growth rate in the US and other MDCs, more developed countries, the growth rate is low. Developing countries, LDCs, the population is growing very rapidly. Worldwide, if you average it all out, interestingly enough, there are more than 4 human births every second. So what does that mean for our Earth and our species? Population growth for most of human existence was slow because life was harsh. Food was hard to find, predators and diseases were common, life-threatening. So these limiting factors kept death rates pretty high. Until fairly recently, only half children in the world survived to adulthood. Because death rates were so high, families had many children just to make sure that some would survive. As civilization advanced, life became easier, and specifically the Industrial Revolution changed a lot. In the Industrial Revolution, there was improved nutrition, sanitation, medicine, and healthcare. These all caused the death rate to go down, but the birth rate still remained high. So the lower death rates and continued high birth rates led to exponential growth, which is what you see right here, this upturn at the time when the Industrial Revolution begins. But that can't continue forever. I think you guys have heard the name Thomas Malthus. He was an English economist. We brought him in when we were talking about the study of Darwin and Darwin's readings. He took Malthus's theories and Hutton and Lyell, but Malthus suggested that only war, famine, and disease could limit population growth of humans. He thought that human populations would be regulated by competition in the form of war, limiting resources in the form of famine, parasitism in the form of disease, and other density-dependent factors. And like I said, his thinking was very important to Darwin's theory of natural selection. Exponential growth continued up until the second half of the 20th century. It peaked around 1962, 1963, and then it began to drop. The size of the human population is still growing rapidly, but the growth rate is slowing down. There are social and economic factors that affect human population growth. Birth rates, death rates, and the age structure of a population help predict why some countries have high growth rates and others have low growth rates. The study of human populations and all aspects of a population is called demography. So the characteristics of human populations are studied, and they're used to try and explain or predict how those populations will change over time. During most of history, human society had equally high death rate and birth rate. But in United States, Japan, and much of Europe, we saw a slowing down of population growth in the last century. This is called demographic transition. It's a change from high birth rate and death rate to low birth rate and death rate. There are 3 stages to the demographic transition. In stage 1, which is over here, birth rates and death rates are high. So that's before the demographic transition. In stage 2, we see technology that help to lower death rates. Nutrition, sanitation, and medicine help to do that. That's right here in stage 2. Birth rate remains high for a time, so births greatly exceed deaths, and this is where we see exponential growth. Now what we see here is the birth rate remains high. That's the curve in red. Stage 3 is further development of the country. Level of education and living standards are rising. Families will have fewer children, and the birth rate falls. And then that's where we see a slowing down of population growth. demographic transition is finished when the birth rate meets the death rate and population growth stops. As mentioned before, the United States, Japan, and Europe have completed the demographic transition. South America, Africa, and Asia, parts of them are passing through stage 2, they're in the middle, and then a large part of human population growth is happening actually in only 10 countries, with India and China in the lead. So only 10 countries worldwide, it's estimated, are still in stage 1. Globally, the human population is still growing rapidly, but the rate of growth is slowing down since the 1960s. Our J-shaped growth curve may be changing into a logistic growth curve. Remember, leveling off. So what we see may be starting to happen is a leveling off there. These are age structure diagrams. You can find out a lot about what's going to happen to a population in the future. So United States age structure diagram is here on the left. Guatemala is the age structure diagram on the right. Here's the United States. What you see is that there are nearly equal numbers of people in each age group. So what you see is it's almost like a column. There's fewer people at the top, but especially in the reproductive and the pre-reproductive ages, it's pretty similar. The post-reproductive, there are fewer people there. But for the most part, there are equal numbers in the other two categories. There. So what this age structure shows is a slow but steady growth rate for the near future. Now if you compare this to Guatemala, you see a lot of children, so high birth rate. Second most number is in the reproductive ages, and then not a whole lot of people in the post-reproductive age. So what we have here is high birth rate and high death rate. So there are many more young children than teenagers, and then more teenagers than adults. This age structure gives a prediction that the population will double in about 30 years' time. Demographers put age structure into the factor to look at population growth and the effects of diseases on death rates, especially AIDS in Africa and part of Asia. Current projections suggest that by 2050, the world will reach 9 billion people. We're at 7 billion right now. There may be a leveling out to a logistic growth curve if countries that are currently growing rapidly go through the demographic transition. So, as you can see here, what scientists are predicting is that out at 2050, you see more of that column-shaped structure, that's the bars in blue, as compared to what we see in 2002, which is in the green. That's what I was just pointing out on the previous slide. Global human population is estimated to grow more slowly over the next 50 years than it grew over the last 50 years. But because the growth rate will still be higher than 0, the population will continue to grow.